Today we take a pragmatic approach on ChatGPT, what it is and what it's capable of. We'll also put it to work, and to be more specific, we'll integrate the GPT-3 API into our own web application to help us improve our coding experience. But stick around and you'll see how we can make a web application that publishes websites online with just one command. So let's get coding. So to begin with, create a new Blazor Server project, leave the defaults and click Create. Let's do a bit of cleanup. In the data folder, delete the weather forecast and weather forecast service. And from the pages folder, delete the fetch data and the counter, because we don't need them in this tutorial. We also need to remove their references from the nav menu, like such. And from program.cs, delete this line and the using. We're going to be working with the index.razor page, and to create the code behind, we just right click on the pages folder and add a new class. And this will be called index.razor.cs. The only change that we need to do is to specify that this is a partial class. Remove everything from the index.razor page because this is where we're going to do the setup. And for now, let's just quickly install a package. Right click on the dependencies, manage NuGet packages, and search for newtonsoft.json because we'll use this to serialize the data that we'll send to the GPT-3 API. The latest table 1 at the time of recording this video is 13.0.2. In the data folder, let's right click on it and add a new class. We need to create 3 models. The first one is the search model, and we'll use this one in index.razor page on our index component to hold the input data, the prompt from the user to be sent to the GPT-3 API. So all we need to add here is public string prompt. So this is a required property, so I'm just going to add the required attribute in front of it, and this will hold the actual input. The prompt is your question or request. It basically is what you are asking for from the AI. You can ask it to explain some code or generate some data or ask some random questions that you want. The next one is the request model. Okay, so the request model has 5 total properties. The first one is the model, and here we'll specify the actual model that we wanted to use. So in this case, we'll use DaVinci, and you'll see in a moment. Then we've got the prompt, and the prompt is your actual question that comes from the user. We've got the temperature, and the temperature specifies the sampling temperature. So this ranges between 0 to 1. The closer this value gets to 1, the more creative the response is. The closer you get to 0, the more exact the response is, but it's also repetitive. We've got max tokens, and this is the maximum number of tokens expected from the request response. The maximum value we can use for DaVinci is 2048. We've got the frequency penalty, and this is between -2 and 2. The smaller the number, the more likely the model is to avoid repeating the same line in the response. And let's also create the constructor. So we'll just quickly define the model prompt, temperature, and max tokens and frequency penalties. Okay, the last model that we'll create is called a response model. And obviously, as the name implies, this will hold the actual response from the AI. This has got 4 properties: the ID, the identifier, the date created, the model, and the choices. And this is just a new class that I'm going to add in here that holds the actual text and the index. So why is this an array? Because the AI responds with multiple choices, and you can choose whichever one fits your purpose. We're going to always choose the very first choice that the AI is going to send us, and we're going to grab the text from there. So this is the response text. From the request model, this is the prompt, this is our question, this is what we ask the AI, and from the response, this is what the AI responds with. Okay, in here, let's add a simple edit form, and we set the model to a search model that we haven't yet created. We have it to submit to a function called execute that we'll create in a second. Then let's define the actual input text area. So this is the text area that will hold the user's prompt, the question that we're going to ask to the AI. And this is a class of form control. And we bind the value to the search model.prompt because we're going to use the search model in here. It's got the property of prompt. Okay, so we'll define the search model property in a second. It's got 20 rows, and we're going to have it to be disabled while it's executing. So this is a boolean that we'll create in a second along with the other properties and objects. And we'll add another simple button that is going to be of type submit, so it submits the whole form. And again, this will be disabled whilst it's executing. The label of this will be go. And why not? Because we've got access to whether or not the method is still executing. Let's add here a span that's just saying loading. If you enjoyed this tutorial so far, why not hit that like button so that this video can spread to as many wonderful human beings as possible, just like yourself. I would really appreciate it. Okay, so let's start. Okay, so let's go to the code behind and set up some properties. The first one is the search model, and this is of type search model, the model that we've just created. And the second one is the Boolean. So let's import the namespace. And now let's create the actual function, the execute, the function that this whole form, edit form submits to. So this is a protected, asynchronous task called execute. So first things first, let's ensure that the prompt is actually valid. So from the get-go, we check if it's null or empty, and if it is, then we populate the prompt with please ask a question, i.e. write a simple record in C# called person. So this way, anything past this point, we know that it's a valid prompt, so we can create our request with no worries. Then at this point, we'll start the API request. So we set the is executing flag to true. Okay, so this will be a HTTP request message. This is how we're gonna build the request. Let's new it up. And this will be a post method to the OpenAPI/v1/completion. This will be the endpoint that we're going to use from GPT-3 from OpenAI, because we're giving it a prompt, say, create me a JavaScript class, and this will complete back with the best match for our request. Okay, so following, we need two things defined at the top of the class, or rather injected. We need the iHTTP client factory defined right here in injected, and we need the iConfiguration because we need to access a specific property from appsettings.json, and that is the actual bearer token API key. And to get this one, so I'm just going to paste this in here with the name OpenAPI token in appsettings.json, so that we can safely access it from within our application. In order to get an API key, you need to either log in or sign up if you haven't got an account already. Go to Personal, View API keys, and in here you can create a new secret key right here, at which point it will open up this pop-up model for you to copy the key and keep a hold of it. We need to go to program.cs and paste in this line here that all it does is it registers the HTTP client service right here in the services container. Okay, so now let's define our HTTP client, and we do this by doing client factory.create client, and we need to define the request headers. And in our case, the only request header that we want to define is the authorization header, and we do this by newing up the authentication header value, and this is of type bearer. We'll use the API key that we've just generated from appsettings.json as a bearer token, so we'll use bearer authentication. Okay, so now let's prepare the request payload, and this is a new request model. The model is the object that we've created, and the first property that we define is the actual model, and we use the DaVinci and the latest version of DaVinci. Then we use the prompt, so the prompt is the search model.prompt. This is what the user has inserted, the question that they have. This is the max tokens, and in this case we'll just use up the maximum of 2048 tokens, and this is equal to about 1500 words. We've got the temperature, and 0 means exact and repetitive, so every time we ask a question, there is a very high chance that the AI will give us the same response because it is very exact at 0. The frequency penalty, this is between -2 and 2, and I've put it somewhere in the middle. Right, and now we serialize the request model using JSON-convert.serialized object. And finally, we pass the serialized request object to a string content into the content property of our request. And we do this by newing up a string content object. We pass in the serialized request. We specify the encoding as UTF-8 and the data type as being application/JSON. We define the result and we send the request. And we keep a hold of the request object. So we do client, so the HTTP client.send async, and we send the request object with everything that we have defined so far. At this point, because we're waiting for it, we can define the isExecuting flag as false because we've finished the request. And now we need to check the actual result object. So we do if result.isSuccess status code, then grab a hold of the response. So we do that by awaiting on result.content.readFromJSON async, and the result will be of type response model. So again, this is what the response model will look like. And we're worried about the choices property. So this is what we're going to do next. Let's check if the response is not null, because obviously if it's not parsed correctly as a response model from the JSON result, then it will be null. Then let's see if we've got any choices. If we don't have any choices, then we don't have anything to parse. And also we need to ensure that the very first choice .text is not null or empty. And if everything passed, then we set the prompt as the very first choice text. Otherwise, if any of this returns false, meaning if the response is null or we don't have any choices or the response text from the first choice is empty, then we just set the prompt to no results for this search, please try again. And hey, I just wanted to let you know that on this channel we've got tutorials just like this one, so if you enjoy, hit subscribe and join the club. Okay, let's give this a go. So this is what it looks like. It is pretty simple in design, so let's ask it a few questions. Write a person class in C# with the following properties: person ID, first name, last name, and age. And as you can see, we've got the whole thing disabled, including the button, and we've got the span showing up because the request is still executing. And after a few good seconds, we've got our person class showing up right here. Let's play around with some more examples. Write a migration in entity framework that creates a people table. This is a pretty long piece of text that it sent us, but as you can see, I mean, it actually created the table. We've got the name of the table and we've got the columns as well. But you'll see that we've got a very simple instruction, a very simple prompt, or we can get really granular with the details. Create a query that generates data for this table, and we can give it the table name. And it's actually able to figure out that this is an ID, the identifier as an integer, this is a string, and this is an integer as well. There you go. We've got insert into people, and then we've got 4 rows of values. But also, apart from that, you can ask it what is wrong in the above piece of code. And in this example, we've got what is the above class missing. And obviously, we've got a few properties, but the above class is missing a constructor. So this is pretty useful. I mean, it can even get to a point where you paste in a class and it tells you exactly what the bug is maybe in the future with more and more training. But we can take it to the next level, so we can have it to build our own website for us. Okay, so what we'll do now is we'll create an automatic website builder with the help of GPT-3. We'll send a request to GPT-3 to create a website for us. It will give us the markup for the index.html page, and we'll take that markup, we'll validate that it's valid HTML, and then we'll create a website from it. So we'll create 2 things, a GitHub repository and an Azure static web app. The GitHub repository will hold the list of HTML files that we'll create with the help of GPT-3. We'll deploy these HTML files publicly so we can have access to them. So in essence, we'll ask GPT-3 to give us the syntax for a basic HTML page. We'll take that HTML syntax, we'll validate it to make sure that it's valid HTML, and we'll push that to our GitHub repo, at which point release will get triggered and that new page will get released publicly with the help of GitHub Actions and Azure Static Web App. So the first thing to do is create a new repository, go to your GitHub account and click new, give your repo a name. I'm just going to call mine codebody-1. I'm going to make this private because this doesn't need to be public, and click create repository. So this repository will be the container for our HTML files that we'll create with GPT-3. If I create an index.html file right here, save these changes, and we've got our website right here. So the way we publish this is by going to Azure, click create new resource, type in static web app, and click create on the static web app widget right here. Just call this code buddy. It will automatically create a new resource group if you don't already have one. And The plan type will be free, so for hobby or personal projects. And the source is defined as GitHub right here. If you were to have an Azure DevOps, obviously you could select the Azure DevOps Git repository. So we've created the GitHub one. Select your organization and the repository that we've just created, with the branch selected to main. Click review and create. So now every time we push to the main branch inside this repository, the actions will get triggered on this repository, thus releasing it to these Azure Static Web App. As you can see, GitHub Actions right here, deployment history, and we can see the GitHub Actions. And obviously, it's going to send us to the GitHub repository. As you can see, we've got two workflows that have been triggered automatically by us creating the Azure Static Web App. So every time we'll push a new file to this repository, another action will get triggered right here, which will in turn publish our files to the Azure Static Web App, which will publish them obviously to production. As soon as this is finished, we go back to the Azure Static Web App, and if we access the URL, you will notice that this actually serves the index.html file. We'll create a websites folder inside our repository where we'll publish the HTML files that GPT-3 generates for us on request. Just make sure that you keep a hold of this URL because we'll need it in a few moments. We need a way to switch between the code body, so the version that we've just created, and the website builder. To do that, we'll use a bool flag that we're going to define right here in the index.razor.cs, because we don't want to create a new page and having to copy all this logic in there or to extrapolate this into a service. Just to save all that effort, what we'll do is we'll take this component right here and we'll make it to turn between a website builder and the code body, the code generator that we've just played around with. So below the is executing, we'll define a new bool flag that is called isBuilder, and by default this is false. So we'll have a switch in here in the HTML to switch between the builder version or the non-builder version. So basically what we've got now. Let's add a heading so we can ask questions to our page. If this is a builder, if this is the code helper, then we can just simply ask questions to GPT-3. Otherwise, we'll just have it to generate HTML markups for us. And this is the switch. This is the switch markup right here. So we're adding in a div container with an input and a label. It binds the value to the isBuilder flag that we've just created. As soon as we toggle this on or off, it will toggle the isBuilder property. We're going to use the isBuilder property later on to figure out if this is supposed to be HTML markup that we're expecting from GPT-3 and therefore push that to the repository, or if it's not a builder, then just simply ignore the logic where it attempts to push to the Git repo. In order to ensure that the HTML that's generated by GPT-3 is actual HTML, in other words, we need to validate that the response is of HTML. So to do that, we need to install a package called HTML Agility Pack. The latest stable version is 1.11.46. The other package that we want to install is called OctoKit, and this will give us the ability to push to a GitHub repository. The latest stable version is 5.0.0. Right, so in here in the index.razor.cs file, instead of just setting the response text straight to the prompt, let's save it in a variable right here. Let's set the response text variable to the response to the search model.prompt. And in here, we can check if this is the builder mode or the normal code body mode that we've played around with. If isBuilder, do the code that we're about to write in a second. Otherwise, treat this as you've treated it before. Just append this to the response text. Let's configure it to actually validate the HTML and push the change to GitHub. So to validate the HTML that's returned from GPT-3, we do HTML document. This is the type. This is from the Agility Pack, HTML Agility Pack package that we've just installed, HTML doc, and we're newing this up. Then we do HTML doc.load HTML, and we load it up with the response text. If this has got any parse errors, in other words, if the HTML doc.parse errors.any, it means that we haven't got valid HTML right here. We set the prompt to no valid HTML response, see below, and we append the response text to the prompt so we can see whatever GPT-3 responded to us with. But then, in order to be able to push to our GitHub repository with the response text, because at this point we know that we've got valid HTML, so let's go ahead and push it to our repo. But in order to be able to do that, we need a GitHub token. We head over to our profile image right here, and we go to settings. We scroll all the way down to developer settings. And in here, we go to personal access tokens, tokens classic. And what we need to do is generate a new token. Generate a new token classic for general use. We put a note right here and enable only the repo section. We want our application to be able only to see the repo status, to see the repo deployment, and to essentially be able to push changes to our repository. Anything else stays the same, and click generate token. Grab a hold of this generated token, come back into our application, go to appsettings.json, and let's create a new property called CodeBody token, at which point we can paste this in, save, and go back to our code behind. We initialize the GitHub client, and we're doing this by doing new, and inside the constructor, we pass in a new product header value. Then we define the credentials. We're newing up a credentials object, passing in the CodeBody token that we've just generated from our GitHub account. Then we define a path extension as a GUID.NewGUID. So this would be a unique identifier that would be the name of our HTML file that will generate. So every time we request GPT-3 a new website, then we'll take that HTML and we'll generate a file with this particular name .html, so that we know that every single file that we generate with GPT-3 will be unique. Then we define the variable owner as being the GitHub username. Then the repo name is CodeBody-1, and the file path is a website /path extension.html. So this is where we'll push our code. The branch is set to main, and like I said, this is the URL that's been generated by Azure Static Web App for you. So copy this and paste it in here, and we'll do /website/ the name of the HTML file that we've just generated. So we define a create file request by doing a new create file request, and this is the commit message, inserting a new website. We set the response text, so this is the HTML file that we're going to push to our GitHub repo, and we define the branch as being to main, so we'll push it straight into main. Then the last step is to do GitHub client.repository.content.create file, and we pass in the owner, the repo name, the file path that we've defined right here, and the create file request. So this is the request to create a new file inside our GitHub repo. And let's actually grab a hold of the website URL. So the new website URL would be a string. So we save that as a property inside our component. Define the new website URL as the generated URL. Add the using to octokit.productHeaderValue and to alias that as product header value. Okay, switching to the builder. So let's ask it to create a modern looking HTML website with images. It's going to take its time, but after a while, you'll see that it finished. So we know we're in the builder, and we did HTML.load HTML, and there we go. We don't have any parse errors. So we're going to get straight into the else block right here. We define the GitHub client. We set the credentials of the GitHub client. We define a bunch of variables. And as you can see, the path extension is a unique. So this is the unique name of our HTML file. We set the generated URL right here. Actually, it would be a good idea to actually show this so that we can click on it and navigate straight to it. Okay, so at this point, we are creating the file and hit continue. So now if we head over back to our GitHub repository, if we head over to the actions tab, you'll see that inserting a new website and then the website name. And if we go to the code, we've got a brand new websites folder right here with our website. So this is what it's generated. This is the website that GPT-3 actually generated for us. The CI/CD pipeline has been triggered right here, and as soon as this finishes, we'll be able to access this unique website by doing this URL.html. So if we navigate to URL, then do /website/uniquegui.html, there we go. We've got a website that's just been generated for us. And let's do it again. And actually, if we go back to the application and copy the new website URL, we do an if statement to say if this is the website builder, then show a couple of paragraphs to say below you can navigate to your website and then the new website URL. So we can click on it actually when it's generated. If we run this again, let's switch to the builder, ask it to create a modern looking HTML website with images from the internet and Bootstrap. We'll notice that a new workflow has been triggered for us. Okay, back into our application, click on the website, and there you go. We've got a brand new website, single page website generated by GPT-3. Thank you so much for watching. If you enjoyed this video, please don't forget to hit like and subscribe to this channel because we've got tutorials just like this one. Until next time, stay safe.